And here are some suggestions for the matching analysis. For static and dynamic parameters, they should be within reasonable range. For the dynamic parameters, because it is not very commonly seen in other areas, so we have some suggestions in our software. And for static parameters like unit shaft resistance, unit toe resistance, so that requires the engineers, they have some background knowledge of the geotechnology. And the matching time after 2L/C should be no less than 20 milliseconds and 30 milliseconds for diesel hammers. So actually it's decided by the sample length. So that reminds us to make sure that our sample length while collecting is longer enough. Because we have met some problems from our customers, they give a data with the sample length of only like 50 milliseconds. So it is too short for matching. Good matching requires calculate curve meets measured curve, especially during the first 2L/C. And that's how we calculate the match quality MQ. If they do not meet very good, match quality MQ value will be very big. Soil quake should not exceed actual displacement of the soil segment. And the calculated set should be close to the measured one, because the measured set is inputted by the engineer. And also the software will calculate a set, and the two values, they should as close as possible. Now we give some examples for different parameters, how they work during the match. Take this for example. If we increase the total capacity by 10%, we can see that the calculated plot, which is the blue dashboard line, it increased around the area of 2L/C. And if we decrease shaft resistance by 20%, we can see that calculated force will decrease before 2L/C. And similarly, if we decrease SS from 0.7 to 0.4, also the part before 2L/C will decrease because SS is used to calculate the dynamic shaft resistance. The previous slide, the shaft resistance, actually it's the static shaft resistance. It will decrease the calculated plot. And also dynamic shaft resistance. If the dynamic shaft resistance is decreased, also the calculated plot will decrease. Then is the UN, unloading loading resistance ratio. We know that the UN will affect later part of the plot. So you can see if we decrease the UN from 1 to 0.3, we can see the plot go up a little. Anyway, for this plot, it's not very obvious. You may try using your own data. Decrease UN will increase the calculated plot in the later part. Shaft unloading loading quake ratio, CS. If we decrease CS, we can see that the later part of the calculated force is decreased. Because CS is used during the unloading part, and unloading part is after 2L/C. This is unloading part, so it will affect the calculated plot after 2L/C. Plug, PL, soil plug. If we increase soil plug, then we can see there is change around the time 2L/C. Okay, that's all for the training. Thanks for watching.